Good afternoon. Welcome and Happy New Year. Thank you for joining us today for our webinar. My name is Amanda Height. I'm a member of the Illuminating Engineering Society and a local Raleigh Section Committee Education Committee member. Today's webinar is sponsored by the Illuminating Engineering Society Raleigh Section. After brief introductions, we'll be watching a pre-recorded talk that was done at the IES national level. It is entitled Controls and Measurement Compliance. At the end of the talk, we'll have an opportunity to have a live Q&A session with a controls expert. So as I mentioned, please type your questions in the chat and we'll be looking for those and we'll answer them at the end. I'd like to welcome our guest today. Matt Kennard is the Southeast Region Sales Manager of Universal Douglas Lighting Americas. He has over 15 years of experience in lighting controls market with 12 years of experience working on controls manufacturers with an emphasis on low voltage lighting control design for commercial and industrial sectors. He has 3 years working at the lighting agency level, focusing on energy code forward selling and guidance for specifiers. He has detailed experience with multiple controls products. He's experienced designing around energy code compliance for national level accounts and is versed in common practices to achieve energy code compliance. And he's an AI education provider in his own right. Welcome, Matt. Thank you for being here.
Thank you guys for having me. Happy to support the Raleigh chapter of IES and help you guys bring some clarity to this arguably complicated subject.
Really looking forward to it. Our objectives today are to review best practice lighting control design application for multiple common space types and avoid common code mistakes and misunderstandings. We'll learn the challenges that lighting designers and engineering professionals face while designing building lighting power and controls to meet those codes. And we'll hope to reduce the confusion or challenges for lighting designers and engineering professionals when designing building lighting power and controls to meet codes. So without further ado, here's our presentation.
Most of us are familiar with is the ASHRAE IES 90.1. That is the federal standard, with the 2019 being the most recent version that was just released at the end of this last year. Also, we have the International Energy Conservation Code. The 2018 is the most recent version of that. This is the most predominant code that is being adopted throughout the United States. It's written specifically for jurisdiction adoption. It allows the ASHRAE IES 90.1 code as an alternate compliance path. And then for those of us up in Canada, is the National Energy Code of Canada for buildings, with the 2017 version being the most recent of that. So how are these codes used on a state-by-state or province or jurisdiction basis? Well, states can either directly adopt these codes as they are. In some cases, states will go and make their own specific code that will be very unique, such as is happening in California with its Title 24 code. Or it may adopt the model code as the basis of the code and make modifications to it, such as the 2020 Energy Conservation Construction Code for New York. Also find that local jurisdictions such as cities themselves may also create their own codes. So when we have states that create these codes and they change them, they're often called state or local amendments. Now, an amendment sounds like we're adding to the code, but in many cases they may be making sections of the code optional, or they may be striking them out. And other times they just may be modifying some of the language or some of the energy efficiency requirements to better meet the needs of their local jurisdiction. We're also seeing throughout the United States specifically a lot of stretch codes that are now coming into play. We'll talk about those in a minute, but the intent behind these is to allow the cities to adopt more energy efficient codes beyond the base code that is there inside the state itself. So let's take a quick look at the adoption status that we're seeing throughout the United States. This map here shows on a color code areas that are most energy efficient and most progressive in their code adoption. The darkest colors in green you'll see are states that are either on or following a code at least as stringent as the ASH rate 90.1 2016, which is seen as commensurate with 2018 IECC. The lighter green states are on a code version prior to that, and the yellow states a code version prior to that, assessed based on ASH rate 90.1 2010. And your states in red are about 4 code cycles behind, or maybe further behind. Those states in gray are what we would call home rule states, where they would adopt their own specific codes in the local cities and jurisdictions and counties within those states. But the state itself doesn't have a mandated statewide code. This year, over 25% of our states have or will adopt a new energy code, with almost 70% of those codes in the U.S. will be the 2018 IECC version, or an amended version of that IECC, but again allows the ASH rate IES 90.1 as an alternative compliance path for a building to follow for energy efficiency construction. And while you see states that are behind, oftentimes what can be a challenge for them is when they go and they adopt a code, it usually is a significant code jump, maybe 2, 3, even 4 code cycles. So it's a fairly dramatic jump, both in the stringency of the requirements, the energy efficiency of the building, and for the designer, there's a lot of new things to learn inside the code. When it comes to Canada, Canada, and I apologize for the different colors here, but Canada isn't evaluated the same as the United States against the ASH rate 90.1 code. It typically adopts the National Energy Code for buildings in Canada, but also uses ASH rate 90.1 as an alternative compliance path. So why don't we stay with one version of the code, and why all these changes and amendments, and if you will, stretches of yoga in some of these codes? Well, there's a number of reasons. First is that as the ability for efficacy and efficiency increases, we want to fold those new changes into the code so that buildings can progressively become more efficient and take advantage of that additional energy saving. Second, we often see what we call provisional alignment. That is, that one code is making changes in order to better accommodate changes that they're seeing with other codes, so it's not as difficult to apply the code as a designer or an engineer. We also see that the language and application of code will change. A new code provision may be instituted, such as daylighting, and over time we learn of other things that may change in the construction, or things that were unforeseen when the first code language went in. So the code will improve the language and adjust for easier compliance. Newer technology introductions, such as we've seen with solid state lighting, has certainly changed the code. Shifts from energy savings to climate action emphasis is a significant thing that we're seeing today, where instead of just a return on investment based on dollars and cents in energy savings, we're seeing that some of those costs are being looked at in terms of reduction in carbon and greenhouse gas emissions. So it's going beyond just the energy efficiency that the codes can offer. Balancing building wellness is becoming a growing trend to make buildings a healthier environment for occupants, and it's starting to drive some of the thoughts and ideas on how the codes will fit with this. And yes, can you believe simplification inside codes? You know, sometimes it feels like the codes are continuing to get more complex, but we are seeing some movement towards simplification. An example of that is in the most recently released ASH rate IES 90.1 code of 2019, is that they have provided a table for simplified building method. This one here is for specific for office buildings. They also have a simplified method for classrooms and for retail stores. This allows the control requirements to be not necessarily reduced, but be able to be condensed and simplified for its use, as well as the lighting power allowances for these 3 different building types. There's also a simplified method for exterior lighting as well. This only applies and is applicable to buildings that are 25 or less than 25,000 square foot. So what are some of the changes moving forward with the code? Well, in efficacy and efficiency, we're going to take a look real quickly here at the 2018 IECC, where it has revised the pathways for compliance for dwelling and sleeping units inside buildings. The first path applies to dwelling units that are found in multifamily buildings. That is intended to follow the residential efficacy requirements, which is using high efficacy fixtures in 90% of the permanently installed lighting inside the space. Essentially, no incandescent lighting for 90% of those permanently installed fixtures. Dwelling units found inside commercial buildings have the option of either following the residential efficacy requirements, or they can follow the commercial requirements of the special application control, which is how the controls will operate in these spaces in the dwelling units, and also the interior lighting power allowance for those spaces. And then lastly, the pathway for sleeping units follows a specific application control requirements. This is largely for hotel and motel rooms to have automatic shut off when guests leave. But as far as the lighting efficacy requirements themselves, they're permitted to choose between following the residential efficacy requirements or follow the interior lighting power allowances in the commercial section. So what do these efficiency requirements look like? Well, this is a bit of an eye chart. It does show here, if you look the standard here on the left, you can also see the lamp lumen per watts that are required by that specific code, the luminaire lumen per watt, and also what percentage of fixtures are to be installed to the high efficacy lighting. And what you find here is that the IECC code over the last number of code cycles really hasn't changed its lamp lumen per watt. It's still on a compact fluorescent, if you will, a lumen per watt number. But the number of lamps to be installed has changed from a 75 to a 90% in the 2018 code. And then as you go down the list here, you'll see that the other codes have taken the approach now that they choose a efficacy for the lamps, such as the ASHRAE IES 90.1, which is 55 lumens per watt, and separately has a luminaire lumens per watt, as it shows here, which is 45, and an installed percentage of 75% of the fixtures that must follow this. I think the key takeaway for this, and the tip for us, is that we need to check closely on dwelling unit efficacy requirements, because as you see across these codes, each one of them has a different lamp and luminaire lumen per watt versus what percentage of fixtures must be installed to meet the high efficacy requirements. So from jurisdiction to jurisdiction, these numbers can change, and this is a lever oftentimes that local states and jurisdictions will use to meet their efficiency requirements. So what should we expect from commercial buildings and its lighting power allowances now and in the future? Well, the lighting power allowances typically all flow from the ASHRAE IES 90.1 standard into the IECC and into the Canadian code. More recently, an updated and more coordinated lighting model has been created by the ASHRAE IES 90.1 committee. It's been coordinated with the IES specifically to make sure that what we are following is the recommended illumination levels inside those spaces. And essentially, it's moved the lighting power allowances all to a solid state lighting technology, where in the past it was a mix of fluorescent and solid state lighting. However, even though we've got these tables and they're shared across the model codes, we're seeing that states themselves now and jurisdictions are creating their own tables or modifying this table to create even more stringency, because oftentimes the codes, in terms of when they actually go into effect, lag behind where the industry is today inside of lighting. And so I think this is an area really where the lighting industry can give ourselves a little bit of a pat on the back, because we've done an awful lot in changing the efficiency in building by the solid state lighting deployment. So let's take a look at specifically what that looks like in terms of numbers that are out there. If you look here, we've got a comparison between prior code cycle, which is the ASHRAE 2013 or 2015 IECC code for the building area method lighting power allowance for some specific spaces. And you can see here the comparison and change between the last cycle of code and the most current cycle of code that's going into effect. In some places like the offices states, the lighting power allowance is slightly reduced. In other areas, you're seeing larger changes, like in the retail and warehouse areas, where we're getting down to, in the warehouses, at 0.48 watts per square foot using the building area method. So what does the future look like for us in the new building and the new lighting model that has been created? Well, even more significant drops if you see here in the lighting power allowances. These are not allowances that are in effect now or probably won't be for the next few years. But I think this will challenge us as designers even more so to be careful about how we design our projects. And if we look even further out, we look to what California is doing in their Title 24, you can see that they're about the lowest that there is in terms of lighting power allowances. And I would say that the state of Washington is probably on par with where California is here as well. So the tip here is that we should really check with our local state or jurisdiction for amended lighting power allowance tables. A good example of that would be the state of New York. The state of New York adopted the ASHRAE, the IECC 2018 lighting power allowance tables, yet the city of New York has modified that table or amended that table for even more energy efficiency inside their buildings. So let's take a look real quickly at what's happening for exterior lighting power allowances. This is an example of the code of the 2013 ASHRAE and the 2015 IECC. And then you can see the changes that were made both in the base allowance and in the watts per square foot or linear foot when we talk about walkways that took place from that code cycle of the 2013 ASHRAE and 15 IECC to the codes that are now going into effect. And in the future, interestingly, there has been no adjustment in the exterior lighting power allowances for future code cycles like the 2021 IECC and the 2019 ASHRAE. And then just for comparison's sake, you can see what the lighting power allowance for exterior lighting is in the most stringent, which is in California's Title 24. Again, these numbers are all based on exterior lighting zone 3, which is your general city municipality lighting that you would see that's out there. So now let's transition and take a look at what's going on inside of controls. As we said, that technology can make changes. Well, the 2018 IECC has added into its code 2 pathways for lighting control compliance due to new technology being introduced into the marketplace over the last number of years. The first choice in a compliance path is to follow the interior lighting control requirements as they're stated. This is more like business as usual and how we handle controls today. But with the introduction of what's called luminaire level lighting controls, it follows a little bit different path in terms of the requirements that apply if luminaire level lighting controls are used in an individual space. So what exactly are luminaire level lighting controls? Well, here's the definition written in the code. It's a lighting system consisting of 1 or more luminaires with embedded lighting control logic, occupancy and ambient light sensors, wireless networking capabilities, and local override switching capability where that may be required inside the space. So these are luminaires that have embedded controls and sensors into each and every fixture, as well as communication technology to allow them to be zoned and regrouped and to be communicated to for adjustment of controls. Well, let's take a closer look at the lighting level control requirements and the provisions they're required to follow inside the code. First of all, luminaire level light controls must be able to monitor occupant activity so that it may brighten or dim lighting. So these are luminaires that must have dimming capability on board, as well as the occupancy detection. They must be able to monitor ambient light level for daylighting control, and then have a series of number of set points, timeouts, dimming, fade rates, and even wireless zoning capability for changing the zones in which they operate in. So what control measures or requirements must the luminaire level lighting control follow? Well, they must follow the occupancy sensor requirements for that specific space and comply with that. They must follow the specific application controls as well as the manual controls for any given space that those luminaire level light control fixtures are installed. The provisions that it's not required to follow, and this is the change in path from standard controls, it does not have to follow time switch controls because it has occupancy sensing built in that will provide the shut-off control capability. Light reduction control does not have to follow it. It has dimming integral to the fixtures themselves, and also daylight responsive controls requirements do not need to be followed. Now it's not that it's not doing daylight control because it has onboard sensors to do daylighting. It's just that it doesn't have to go through the zoning and the definition of the zone requirements for daylighting and some of the other requirements because it will do it inherently as a fixture itself. I think the one thing that is a tip or something that we should be mindful of as designers is that we need to closely review the trade-offs when using luminaire level light level control versus standard control compliance path. Luminaire level light controls introduce a lot of occupancy sensors and a lot of technologies into the space. They can, in some cases, elevate the cost and also the complexity. But they definitely are technology very advanced and provide a lot of capability, even benefits beyond the energy savings themselves for a space. So another significant change that's happening is in the area of open office control. Open office area control in the 2018 IECC at the core is about having occupancy detection inside open offices. Now, we've been putting occupancy sensors for many years in open offices, but this is the first time that it's been adopted as mandatory inside the code. And besides it being mandatory in the open offices, it also restricts the size of the area of control. That area of control is fixed at no greater than 600 square feet. Each space has to be individually controllable for shut-off or reducing the light level within 20 minutes of an occupant leaving the space. If a space has no occupants, it has the option of either fully shutting the lights off or just reducing the light level by at least 80% of the full lighting output, which is essentially setting the lighting to 20% level or less. Then when there are no occupants in the entire open office area, it's measured across all the individual 600 square foot zones or areas, all the lighting must completely shut off, even if it is at a dim level because there might not be occupancy inside that individual space. We'll walk through how that looks in a minute in an application. So how does this implementation of occupancy sensors in open office differ from the applications in other spaces that use occupancy sensors? Well, essentially is that it doesn't follow all the same requirements as standard occupancy sensors in the list of spaces that are mandated for occupancy sensor control. Those specific requirements are there is no requirement for how the lights are to turn on. So it's left to the discretion of the designer to make a decision as to how those lights should turn on. Should they turn on automatically? To what level should they come on? And also, should they be manual on control? Also, there's no requirement for manual off control inside the space, and therefore no requirement for controls in every individual 600 square foot zone. The only exception to this requirement is for offices that are less than 300 square feet, where it defaults and falls back into the standard occupancy sensor requirements. Let's take a look at a layout of a simple open office area. You see here, This area, if we were to divide this up into 3 zones that are less than 600 square feet, might look something like this, where we have a division across that fit within the furniture system that's there inside the space and fitting with the luminaires. As these lights might be off as soon as these spaces become occupied, either by a manual switch or by detection of occupancy based on the decision of the designer, the lights would be on at the light level needed for the task level of work that's happening inside that space. If at the end of the day, individuals leave to the middle zone and the zone on the right, those lights could shut all the way off if that's the design of the space. There's someone still in the left-hand space, those lights would remain on at the prescribed level that either they had set or as the system had set them. An option to this is the lights would not fully turn off, is that they could reduce down to a light level that could be no greater than 20% light level of lighting power. But then eventually when that individual leaves the last space, the entire open office would shut off. So the decision that is made by the designer is should I allow each individual zone to simply shut all the way off when there's no occupancy in the area? Or do I want to cross-coordinate across the zones so that each individual zone knows if there is someone in a remaining zone before shutting the lights entirely off? What does that look like in terms of design and installation? Well, if you look closely at this space, we have the 3 zones, but additionally with a curtain wall window there at the very top of the drawing, you see that we have a daylight area. And so even though we may think that we have 3 zones of control because we have 3 independent 600 square foot areas, we also have the primary daylighting zone will create an additional zone or subzone in each of those individual occupancy sensing detection zones. On this drawing, you can also see here's the occupancy sensors typical for one zone, their placement. The light level sensor detection for the daylighting. Manual switch over on the wall at the entrance to the space that can be used to set the light level or turn the lights on and off manually. All of the switches, sensors, and come back to the central controllers here that are handling all of the control within inside the space. And you also notice inside this space that we have some emergency lighting. Many codes now are requiring that the emergency lighting also be shut off with the other lighting inside the space, and therefore oftentimes will require some control mechanism like a emergency control unit. Usually it's a 924 unit that will allow these lights to switch with the controls, yet in the event of a power failure that the lights would be able to be forced all the way on. So let's take a real quickly at what that sequence of operation might look like. Now, best practice is that we would provide a sequence of operation so that it's clear to the bidding contractor, to the electricians doing the installation, those doing the functional testing, and to be left behind for the owner's use is a sequence of operation for how that space is intended to operate. This is an example of that space using individual control that shut off the lights in each individual zone. So lighting in each individual zone independently comes on or autos on to the last level when occupancy is detected inside the zone. Second is that we have a manual on, off, and dimming control for all the lighting by the wall switch dimmer. Then in the daylight areas, we are going to continuously dim to maintain a 35-foot candle level at the task level. All the lighting in the space will then auto off in the individual zones independently within 20 minutes of the last occupant leaving that individual space. And then last sequence of operation would detail out that the emergency lighting will transfer to emergency power source and the full on with loss of normal power. So however, local and regional codes could make their own amendments to this requirement that may look like this, and this is an example inside of New York City. Even though the 2018 IECC applies that requirement to open office spaces, New York City has taken it a step further and applies that same 600 square foot control area beyond the open office to cafeterias and fast food dining areas. And additionally, they've also changed their time delay from 20 minutes down to 15 minutes of when the occupant leaves the space. So a tip for this is that we need to evaluate which shutoff method of control is going to work best for the owner, occupant, and their budget. Will they go with shutoff for each individual zone, or will they reduce the light level in each individual zone when there is no occupancy and then shut off the entire area of open office, or in the case of here in New York, the fast food dining area or cafeteria, when there's no occupancy throughout the entire space. So that's it for open office area control, a pretty substantial change. Let's take a look at what changes are happening with the daylighting controls. So daylight responsive controls over time have come into the code to be automatic, and at its core what it's intending to do is simply to reduce the light level when we have an adequate contribution of daylighting for a given space. Based on the code, it might be permissible to do continuous dimming, or you might be able to choose step control. Some codes restrict continuous dimming in certain spaces. The IECC does. It restricts continuous dimming must be used for side lit automatic daylighting control in classrooms, labs, library reading rooms, and office spaces. All others may choose to use step control. Most other codes allow you to use either one. Daylighting control must be able to turn the lighting all the way to off if there's adequate daylight contribution, and the calibration of the daylighting controls must be readily accessible. The thing that we have seen that has been fairly consistent for a while, the last several code cycles, is that the primary daylight area is defined by a space that has 150 watts of lighting inside the daylight zone. However, more recently, we're seeing that this wattage threshold is being modified or amended by local jurisdictions. California, this threshold is 120 watts. The New York City Energy Conservation Code and Massachusetts has changed this threshold to when there's 100 watts of lighting inside the daylight area. And in the state of Washington, its specific code is whenever you have 3 fixtures or more inside of a zone, it applies. So what next is changing with daylight control inside the daylight zones? Well, we're seeing more alignment between the codes and how the daylighting area is defined. As an example, today and with the 2018 IECC as well, that code requires a single primary side light area. In this example, you see the windows here on an exterior wall in a simple graphic. Here's your primary side light area. The depth of the space is the head height of the window, so measurement from the top of the window to the floor is the depth. And then your width of your daylighting area is defined by 3 different dimensions. That would be the width of the windows, summed together, adding 2 feet at the end of your primary side light area. And then if you have opaque breaks between the windows, add that dimension as well, as long as that opaque break is 4 feet or less. Otherwise, it would divide it into a separate daylighting area. What's aligning in the codes is what we are seeing here, which is the code for the ASHRAE IES 90.1 and Title 24 as they define the side light daylight area. Again, we have our exterior wall with windows. Adjacent is your primary side light area. The depth here is the head height of the window, which is the same as the IECC code, but what is different is the width dimensions here is, even though it's 3 dimensions that make up the width, the sum of the windows, the outer dimension on the end is an addition of half of the head height of the window. If the window head height would be at 10 feet, or that's the measurement from the top of the window to the floor, it means that we would be adding 5 feet to each side of the daylighting zone beyond the windows. And the opaque break here in between the windows has to be less than 1 window head height in dimension. Otherwise, this would divide into a secondary, 2 different daylighting zones. The other thing that is different about the about this code in the IECC is the fact that we've got a secondary side light area. Now, when we talk about codes coming together in alignment, the 2021 IECC has now adopted this model here for its dimensions and also the secondary daylight area, where it has not existed in the IECC code yet. So that will be in the coming years. We'll see as the 2021 IEC is adopted, we will see alignment in the daylighting area. So let's take a look at that in application. This is a simple classroom that's following the ASHRAE 90.1 2016 standard. What you see here are linear fixtures inside the classroom, 3 rows of linear pendant mounted fixtures. There's the entrance door over here to the classroom, and over here is the teacher's desk toward the front of the room. You'll also notice that we also have a set of fixtures here in front of the teaching station meant to illuminate the whiteboard and the very front of the room as an accent. At the top of the screen is an exterior wall with windows. So that creates a side-lit daylighting zone here. There's a primary zone, and since this is the ASHRAE code, we additionally have a secondary side light zone. Controls deployed inside this space is, first, you would need a daylighting sensor to be able to handle the light that's coming in from the windows. If you notice here on this blow up, because the picture is rather small, you also see call-outs that are defining which fixtures or designators of which fixtures will be controlled by this daylighting sensor. You see those designations here on these 2 rows of fixtures in the primary and secondary zone. This makes it easy for someone installing and configuring the system to understand how the photocell would affect and which fixtures would be affected by daylighting controls. If you look at the fixture down here that's not in a daylighting zone, you see there is a window adjacent to it, but there's not enough lighting power in the space to deem it for controls. You see that that fixture is labeled as A, the A fixture. Over here, you've got your dimming switch at the entrance of the door, as well as switches up by the teaching station. There's actually a single switch at the door that is able to operate all of the fixtures, the A fixtures inside that space, regardless of if they're in a daylighting zone or not. Over by where the teacher is, they have access to those A lamps as well, and the B lamps in front of the teaching station. Inside the space, you see placed on the drawing your occupancy detection sensors that are doing your shut-off control. All of these devices, the switches, the sensors, both daylight and occupancy detection, are feeding that information to the central controllers that are operating the power and the dimming control inside that space. Additionally, there's an additional controller here that's also handling in conjunction with the lighting controls. It's using the occupancy sensors to do the automatic receptacle control, shutting off the receptacles when the space is unoccupied, which is a provision inside the ASHRAE 90.1 code. Sequence of operations simply looks like this. The general lighting, auto on to 50%. and the receptacles will auto on when occupancy is detected in the space. So this is an auto on scenario. You are able to provide manual on-off and dimming controls by both on the A fixtures, by the wall switch dimmers, as well as manual on-off dim on the whiteboard lighting by the B switch dimmer over by the teacher's desk. And then your daylight area lights will continuously dim, including going all the way off with the daylight contribution and working to maintain at least a 35-foot candle level at the task level. And final sequence is that all of the lighting and the controlled receptacles will shut off within 20 minutes of the last occupants leaving the space. Again, this control sequence, when provided with drawings, eliminates a tremendous amount of confusion and provides specific guidance to those who are doing the installation and setup for the system. After an owner has spent a considerable amount of money to put the controls inside of a space, it's only when they operate properly can they be energy efficient. So this is why these sequences of operation are so important to have in the construction drawings. So what other daylighting adjustments are we seeing in the code? Well, here's an adjustment here that's being added to newer codes. We're now seeing it in the California Title 24, the new ASHRAE of 2019, as well as the future version, the 2021 version of the IECC will now have an exception for what is called projections over windows. This is an exception to the daylighting control so that when we have an overhang or a projection above the window and we cannot receive enough adequate light inside the space, that the daylighting controls would not need to be required. But it does require us to calculate a projection factor for that projection or overhang to see if it falls within the criteria where it would receive an exception. So this is a case where the code is adopting over time where it did not address overhangs for daylighting controls. Daylighting controls were mandatory regardless of an overhang or not. Now the code is better adopting to the construction practices and architectures of a building. Another example of a change is in daylighting controls in atrium areas. It wasn't clear, or has not been clear in the code, how the atriums with a skylight apply, especially when you have intermediate levels of floor. So this clarification is in the new ASHRAE. It's in the Title 24 code in California and will be part of the 2021 IECC. Where you see here in an atrium, the top level is considered, the top floor is where you would have daylighting control only in the top floor area based on the requirements of daylighting for a skylight. So it's just like a skylight where you've got a measurement of 0.7 times the ceiling height. That's how much space it goes into the floor onto the top level of floor. But the intermediate floors are not required to have daylighting control. Not enough light will come down from that atrium to make a substantial impact on the lighting in those spaces. However, the area that is considered directly underneath the skylight, those are all areas where daylighting controls would be deployed for any lighting that's affecting or providing lighting for those spaces as long as it meets the wattage threshold requirement. So what other interior lighting control changes are there? I think the ones that we just went over are probably the largest. There are some other ones. We're seeing a continued trend toward automatic reduction of lighting when the lighting is not needed. We've seen this in warehouses, but also in some of the codes, we see it deployed in corridors, lobbies, library stacks, parking garages, stairwells, and labs. And we're even seeing it happen like in this case of the brand new New York City code. We're actually seeing it happen on egress elimination and exit access areas of buildings, where we might have long corridors or areas to allow emergency access of people, that instead of allowing those lights to burn all the time, that they would reduce by at least 50% in order to save that energy when no one is inside those spaces. Other changes with the interior lighting controls, what we've seen is more clarity with the specific application lighting. That's your task, your case, your display lighting. Some clarification that this independent control that the codes have listed in there is a separate manual control device, so an additional switch so that individuals can operate those lights independent of the general lighting in the space, as well as clarity to make sure that it's clear that the automatic shutoff controls are required for these spaces as well, whether it's by occupancy sensor or time switch based on the requirement for that those individual spaces. So more clarity to those lights for control. We're also seeing added to code, particularly ASHRAE and the California Title 24, is that emergency lighting being required for shutoff. But it does provide an allowance of watts per square foot of the gross building area for lighting to remain on for egress lighting paths to meet their minimum life safety requirement. Next is that we're seeing a move over to more dimming inside spaces. So we're seeing this for demand response purposes, such as California's Title 24. We're seeing it in daylight responsive controls that we've talked to, moving more to continuous dimming. In fact, now the ASHRAE 90.1 2019, all daylighting spaces must use continuous dimming. Step control is not permitted. And it's also a change that's coming forward and being adopted in a newer version of IECC, the 2021. We'll have it required for all spaces. Dimming is now much simpler for us to implement, as the LED lighting and drivers of today make implementation of dimming much simpler and it's much more cost effective to do so. Besides that, dimming really improves the usability by occupants in the space. They can better own the space and set the light level to what's best for their needs. And I think going forward, as we see more need for grid stability response, we can see dimming grow more inside the codes. It's not in ASHRAE and IECC yet as a requirement for all spaces, but it very well could happen in the future. In exterior lighting, not a tremendous amount of code changes. We are seeing a little bit of language change in the 2018 IECC, your facade and landscape lighting that needs to control and be able to shut off independent of your parking lot and other lighting. See a little bit tighter language about the time frame that it should shut off within 1 hour after business close, up to 1 hour come back on, and come on up to 1 hour before business opens. And also, or it must shut off at least between midnight and 6 a.m. if it's not in conflict with the business operating hours. We also see a change in all of the other exterior lighting that's not considered facade and landscape. It has a terminology now that's called setback lighting due to the fact that it is to set back or reduce light level at certain hours. Most codes, that lighting is reduced by 30%, but we're seeing that change to 50% in some of the codes. It's 50% in New York City. It's 50% in the ASHRAE 90.1 2019 standard as well. Not a lot of change from the other requirements in terms of time frames or options on how to reduce that lighting. And then we are seeing more codes are adopting that some parking lot lighting, if the poles or the fixtures are mounted 24 feet or less, that they must or are mandated to use occupancy sensor controls for the lighting setback. So lastly is, where can we find help for designs compliance for energy efficiency codes? Oh, I got one tip for you. make sure that in your designs that you properly address the facade and landscape lighting control separate from the other exterior lighting. That's your parking pathway, plaza, and walkway. That as you design those, that they have independent control so they can shut off and be controlled independently in terms of their time frame to be in compliance with the code. So let's move on to compliance help as we wrap up. Compliance help, we can find the code. Almost all codes are available on a free access view. Can't print from it, but you're able to access it and see it online, or they can be purchased from the ICC, from the NECB, or from ASHRAE if you want hard copy. Also, there are compliance manuals that typically come with each of these codes that will walk you through the application, somewhat like I did today, and also show examples and sample calculations so that you can follow through how the compliance occurs. Also, you can look to the IES standard. The LAM 713 standard has got a lot of good information from the Lighting Energy Management group that will help you with code compliance and how to apply controls, as well as controls far beyond just what is essential for basic code compliance. Other online resources that are available to you, the Lighting Control Association's website has a lot of good content and training. States oftentimes offer online training and resources. An example out in California is the Energy Code ACE, and manufacturers oftentimes have a lot of good content and training materials, as well as example space layouts and designs that you as a designer can easily utilize. Codes also have hotlines that can be called either with the state or directly with the code in the case of the ICC. And lastly, states and organizations such as the IES and this webinar oftentimes offer training. I would encourage you to take advantage of those in your local chapters in IES, or also in Light Fair or other places where we have lighting conferences. We'll have training on code and information on code adoption and compliance. So that about wraps up the information that I wanted to share with you today. Code is a very broad category, covers a lot of area. There's a lot of codes and a lot of things to watch for, especially as states and local jurisdictions work hard to have buildings become more energy efficient and strive, in many cases, to meet their climate action goals.
All right, well, welcome back, Matt. Harold certainly presented a lot of information, and I wanted to just get sort of your first initial thoughts on what he had to say.
Yeah, I think clearly Harold is excited and very well versed in all aspects of energy code. Wow, that was a lot to take in. A couple notes that I jotted down here that I think everyone should, that'll make your lives maybe a little easier is, generally speaking, there are certainly alternative compliance paths. I think he hit upon that greatly, IECC and ASHRAE, right? I think that from a designing standpoint, it's important to keep in mind the differentiation, especially when it comes to interior lighting controls. Some of those that I wrote down that are inherent are receptacle control is typically going to be a requirement for ASHRAE 90.1. There's also going to be, as he alluded to, daylight harvesting zones beginning in ASHRAE 2016, compliant with that. IECC, I believe 2015 on, doesn't require those things. So the designs end up being a little more, I guess, simplistic in nature. So you'll have one daylight harvesting zone, and you may not have to do receptacle control in any of the spaces. So I think it's a good idea to take those things into consideration. Obviously, you're going to be beholden to your jurisdiction, whatever code that they have adopted, right? But there are other things I think I mentioned or I liked that Harold mentioned rather. One of those I think is just that controls are evolving. They start up, this is obvious to everyone, they start on the coast and work their way inward, generally speaking. So whatever California and Washington and New York are doing, it's great to have, folks like Mr. Jepson come on and tell us about those sort of things. You know, I think the majority of the folks on the presentation here are probably sitting in North Carolina, right? So I believe is probably IECC 2015 or ASHRAE 2013 equivalent, somewhere around there. But it's really great to get kind of a snapshot on what's coming down the pike, right? So a lot of this may be, hey, this is future stuff, but it's certainly worth considering, especially you know, just today, what's going to be a code requirement is certainly going to change and it's going to evolve. So I think it's a good point to make. Is they're always evolving, and the idea, generally speaking, is to make controls a more granular portion of the whole lighting control landscape in your facility. So we used to be able to take a facility and turn it off, just on off time schedule, beginning in the day. You know, you turn your lights on business hours, at the end of the day you turn them off, and maybe if you're lucky and you're nice to your employees, you'll allow the lights to flicker right before they permanently turn off and give you the option to override them. That is worlds different from what we deal with today. And what you see is, you know, especially with LLLC, luminaire level lighting controls, and then also the requirements in terms of the individual 600 foot, no more than 600 square foot zoning. The zones get smaller, the amount of components get greater, and every manufacturer, like myself, will put together the pieces differently because all of our stuff does different things. So I think it's great to have that handshake and rely on your manufacturers and these resources that he pointed us to make sure that you're doing yourself a service by making your lives easier and taking full advantage to get your controls designs in compliance.
Well, along those same lines, you know, in my industry, I'm working in healthcare. I'm not currently seeing a lot of push to adopt luminaire level lighting controls. And I know you have a broader perspective working across multiple industries. What are you seeing? Is that, are people opting more for luminaire level lighting controls when there is an option, or are they opting to do more sort of room level control?
I think it's a trade-off currently. I think it's code driven right now. So another one of those conversations is, hey, wireless versus wired. Right, we could talk about that and debate that all day long, right? But we're not going to. We don't have the time to. So I could say luminaire level is great, and there's certainly, you know, individual agendas, I think, and it makes perfect sense. But true to what Harold says, it's definitely great a consideration to know that the complexity is certainly going to increase, and for some. You know, it depends on the scale of the project. If it's something that's divided up into 300 square foot and less areas, fine, that's great. You know, in terms of specification, that's fantastic. That's super, you know, straightforward. But in terms of implementation, you know, if you've got a handheld device in each individual space and you've got to zone them manually in each site, then suddenly, you know, whatever payback or whatever advantages you may be reaping, maybe those start to erode after a bit of time. So I'd say it's fun for everyone to talk about those things like IoT, and every fixture has a node in it. I think that those are client-driven decisions that are made, and I love talking about that stuff. Indoor, you know, positioning, asset tracking, those sort of things are really exciting to talk about. There is still I would say a tendency, certainly, to kind of stick to what's tried and true, unless code dictates that you kind of go into the foray into those areas. That's a long-winded answer, so sorry about that.
Well, no, and I'm seeing that as well, that, you know, unless the code pushes it, there's a reluctance to adopt anything new or different for various reasons. We've got a question here from the audience. You know, Harold mentioned that there are some choices designers can make in certain scenarios about whether to have vacancy or occupancy sensing. Can you go through the advantages and disadvantages of each of those choices that we might make?
Yeah, it's really a fundamental difference, right? So vacancy sensing is a requirement in certain areas of the country. And certain aspects of the code. And vacancy sensing, if you guys on the call here are unfamiliar with vacancy sensing, it's simply the manner in which the lights turn on. So vacancy sensing is when the occupant manually presses some sort of button station or activates the lights manually. The other option is occupancy detection to turn the lights on. So when you talk vacancy versus occupancy, you're only considering the manner in which the lights initially turn on. And that's the difference. If the question is what's the advantage of one versus the other, I don't know that general occupancy on exists today in certain areas of the country. I'm certain that it does, but the idea is to not have it exist. The reason is why turn the lights on to 100% if you may be in that space for very little time and grab a piece of paper off the desk and leave? You know, so you can't get around that occupancy sensor turning the lights on if you're in occupancy mode. If you're in vacancy mode, you know, maybe the light level in the room is perfectly fine for you to do what you need to do and leave the space. Then you don't need to touch that switch on the wall to activate the lights. And that's an inherent energy savings when you're going vacancy mode. So vacancy mode generally is accepted. That mode is generally more energy efficient, I think, in theory.
And I wanted to ask too, I mean, since we have you here as an expert and you've done so many different project types, I'm curious, what is your most challenging project type? Which market sector do you see most challenging from a controls perspective? And how are you creatively solving those challenges?
I would say it's hands down hospitality. So think large conference centers with conditional logic, lots of different lamp types, you know, lots of load types, dimming levels, a lot of requirements, right? So owner driven, you need, you know, you're going to have weddings here and high profile events in these spaces. The complexity of those type of jobs in conference centers is far and wide probably the most complex. When you're talking secondary ed, primary ed, interior office space, I would say it's pretty cut and dry because most all of lighting fixtures these days that go into those spaces, your A and B type light fixtures are going to be 0 to 10 volt control. So that takes a lot of the complexity out. So when you get into those architectural spaces, then certainly the compatibility beast kind of creeps into the design, right? And so that's certainly a consideration, I think, for anyone that's in that capacity and designing those type of projects on the presentation here is those take a little bit more of kind of maybe a refined touch and going through and making sure that you're compatible. You're using ELV devices to dim those down to the appropriate levels, MLV devices.
Okay, and then we have one other question. You know, this is the beast we've all dealt with for a while. How are we solving unintended shutoffs in these spaces that have occupancy sensing? You know, someone's sitting at their desk doing notes and the lights shut off on them.
That is there's a lot to that. So that is a combination of, application. That's a combination of using the proper technology and design and implementation, the correct number of occupancy sensors in the space, making sure the communication on the height of any potential partitions or obstructions is accurately conveyed throughout the channel of purchase and design. And I think that you know, it's cause for optimism in what Harold said, and that you know, the latest versions of the energy codes, you know, when you go down and you shrink your zoning down, then that actually forces you to be more granular in your occupancy sensing zones, and inherently makes you put more devices in the space to be able to detect those people. So I think by design, we're going to see less and less of those sort of false offs, if you will. And the energy code, right? The world's different, as I was speaking to earlier. You know, it used to be, again, you're in a space, you're working late. Oh, it's 5:30. Time clock says shut the lights off. Boom, you've got 10 seconds to make it back there to the wall switch to hit the lights on. Now you've got luminary level lighting controls. So you've got, you know, 6 sensors that are watching you the entire time. Much different story than what we were dealing with in the past. And I think that, you know, as we evolve in energy code adoption and become more progressive, I think that those sort of things will go away.
That's good news. I think everybody will be glad to hear that.
For everyone.
You mentioned codes moving, becoming more progressive and more stringent for energy conservation. And Harold mentioned in the presentation that some areas, like California or individual jurisdictions are adopting what he called stretch codes. Are you seeing any areas in the Southeast that are adopting codes and individual jurisdictions that are more stringent than those surrounding?
I think that the Southeast is a strange place. I think that I think I've seen almost the reverse of that. So I've seen, which I guess would technically be an amendment. So for example, Florida has a Florida Building Code 2017 iteration said it's based upon ASHRAE, and ASHRAE, as we went into quickly, requires receptacle control. 50% of the receptacles in a space must be controlled with the lighting. In the latest iteration, which is 2020, which took effect January 1 of last year, there was an amendment to that particular code to take out that provision in particular. So there's a lot of flexibility, I think. You have the federal kind of ASHRAE is kind of sets the baseline, then you have more of the jurisdictional IECC, which, I mean, in all honesty, probably is from a controls perspective. Not sure what the HVAC portion of that looks like versus ASHRAE, but as it pertains to lighting controls, probably a little more friendly than ASHRAE. But yeah, it just goes to show that what has been accepted by the state can certainly isn't forever. So just keep that in mind. So there's a ton of flexibility in this in adoption and amending after the fact. That's great to have, right? Checks and balances.
Absolutely. Well, and it keeps us on our toes, right? So it just goes to show that, we need to be up to speed on what the current codes are, and like we mentioned, what's coming down the road, and what stretches or shrinks our individual jurisdictions may make. So that's why sessions like this are so great, to just keep our finger on the pulse of everything. Gives us an opportunity to grow and learn and always challenge ourselves. Well, I don't see any further questions from the group. I didn't know if you had any final thoughts. I mean, we've covered fairly thoroughly, I think. But if you had any last words, I'd love to hear them.
Yeah, so happy to be a part of this. Just know that I think it's super important to echo what you said, that to stay kind of get your finger on the pulse a little bit of what may or may not be coming. And then also, manufacturers in general of lighting controls have a plethora of really valuable information to be able to help you through this, because I can't speak to this enough, that it's one thing to get the sequence of operations code compliant. It's another to kind of know what items that are required in the space to make that happen. And that's really where the rubber meets the road. So lean into all your resources locally, your local reps, and your manufacturers that you have access to. They're happy to help.
Yeah, and we always appreciate it.
Sure.
Well, thank you so much for your time, and thank you everyone who's online. We appreciated it, and we'll see you next month.
Thank you, guys.